Today's lesson comes from Chapter 5, Lesson 2 on unit rates, and our goal is to find and use unit rates and unit costs. Rates are a special kind of ratio. What sets them apart are that they actually do have units, whereas when we looked at ratios they did not. So we're still comparing two numbers, but this time we have different units shown. You're more familiar with rates than you think. You see them every time you ride in your parents' car. When the speedometer shows the speed that they're going, so let's say we're driving to Holy Ghost and you're traveling 30 miles per gallon, that's a rate that you're using. Notice I only see one number here. You might be wondering, well, a rate is a ratio, so it needs to compare two numbers. Well, when we look at 30 miles, here's our first number with its own unit. Per gallon means for every 1 gallon. So we really have a 1 understood here, even though it's not shown. So our rate would be 30 miles to 1 gallon. Another place where you might see rates is at the grocery store, when you're buying fruits or bulk food or things like that. So let's say the apples are 3 for $4. Here again, we see a rate. We have two numbers, the 3 and the 4, that we're comparing. The 3 relates to apples and the 4 relates to dollars. So we have different units in comparison. You might see it in the bulk food aisle if it says that, a particular candy is 99 cents per pound. Kind of like the per gallon example at first, whenever it says per pound, it means for 1 pound. We can understand a 1 to be there. So we have the dollars and the pounds as our units, two different units we're comparing. Unit rates are a special kind of rate. They need to have 1 in the denominator. So notice in none of those examples I wrote any of my rates as a fraction, but I always can. So when I was looking at 30 miles per 1 gallon, that would be a unit rate because it has a 1 in its denominator. When I looked at 99 cents for 1 pound, that would also be a unit rate. It has a 1 there. That's what distinguishes it. 3 apples for $4. Well, if I wrote that as a fraction, notice my denominator would be a 4. So that's not going to be an example of a unit rate. It is a rate, but it doesn't fall under the category of unit rate. If I had something like 1 car for 2 people, notice I have a 1 here, but where's my 1 located? It's found at the top in our numerator, so that again is not going to be an example of a unit rate. It's a rate itself, but not a unit rate. Unit rates must have a 1 in their denominator. We can change rates. So let's say that we had 4 cars for 2 people. Notice that's not a unit rate right now. I have no 1s. However, if I divided the bottom by 2, I could get 1 person on the bottom. I know from my work with fractions, if I divide the denominator by a particular number, I have to do the same thing to the numerator. So I could make it 2 cars for 1 person. So I can always change a rate into a unit rate, but if I'm looking for rates that start out as unit rates, they have to have a 1 on the bottom to start. So now that we're familiar with 3 vocabulary words, let's take a minute to get those straight. If I'm looking at a ratio compares two numbers, it has no unit, or it means that we could have the same unit. So 3 jelly beans to 1 jelly bean would be an example of a ratio. The reason being is that we could cancel out those 2 units, so it could look like just 3 to 1. So I could show it like that or like this. Description is that it compares two numbers. It has no unit or the same unit. When I look at rates, a rate simply has the same, or has a comparison of two numbers still. So the example, 1 goal in 5 chances. I'm going to abbreviate. That one's going to go down there. The difference is it still compares two numbers, but it has two different, I'm underlining different units. What's special about a unit rate is that 30 miles over 1 hour, that could also fit into the category of a rate itself, but it's specifically a unit rate. So we're going to put it in this category. Same as rate, but must have a 1 in the denominator. For each of these examples, I need to determine whether we have a rate, a ratio, or a unit rate. When I look at letter A, the first thing I want to do is take a look at whether I have the same units or different units. Since I have different units, I know right away that that must be a rate or a unit rate. Now that I've narrowed it down to those two options, in order to be a unit rate, I know that it must have a 1 in the denominator, and I have no 1s in this problem, so therefore I'm just going to call this a regular rate. When I look at letter B, I first want to look at the units. Notice I have the same unit, ounce and ounces. They're different words only because of the plural, so it's the same unit still. I do have a 1 there. Notice that's not going to influence my decision because first of all the 1 is in the numerator, but second of all because we have those two same units, this is going to be a ratio. When I look at 12 inches to 1 foot, the first thing I notice is that we have two different units. Therefore, it's going to be a rate or a unit rate. Since I have this 1 in the denominator, this is going to be an example of a unit rate. When I look at D, it says 20 miles in 1 hour. First thing I notice is two different units. Therefore, it must be a rate or a unit rate. Since it has a 1 in the denominator, it's going to be a unit rate. At this point, I'd like you to pause the video, try the rest of the examples, and we're going to go over them in class tomorrow. Now we'd like to take a look at how we can go between rates and unit rates. So it tells me here that if Ted makes $56 for 8 hours of work, we want to know what he makes each hour. Well, if I set up the rate for this, I'm going to have $56 over 8 hours. Well, if I want to know what happens for 1 hour, I'm going to have to divide the denominator by 8, and that'll give me 1 hour. If I divide the denominator by 8, I'm going to have to do the same thing to the numerator. Well, I know from my facts that 56 divided by 8 is 7, so I have $7 for 1 hour. In the next example, it says if 3 pounds of carrots cost $1.50, what is the cost per pound? So I'm noticing it says per pound, cost per pound. Notice here it says earn per hour. So my earnings, my money was first, my hours came second. Here my cost should come first, so even though this was the second number, I'm going to put $1.50 as my numerator. And the second thing should be my pounds, so I'm going to put 3 pounds there. Well, I want to know the cost per pound, or what it is for 1 pound. So to get 1 pound, I'm going to divide the denominator by 3. And then if I go ahead and divide the denominator by 3, I have to do the same thing to the numerator. Well, $1.50, if I split that into 3 pieces, it's going to be $0.50 or 50 cents. So it's going to be 50 cents for 1 pound. Take a minute to pause the video and see if you can figure out the cost per day of the cruise that's described. One way that unit rates can be helpful for me is when I'm trying to determine what is more cost effective, meaning what's the better value for my buy if I'm at a store. So here I'm told about 2 sports drinks bottles. One is a 32 ounce and is sold for $1.29. The other is 24 ounces but sells for $1.20. Usually with price examples, what I'm going to find is I'm going to want to put the dollar value on the top of my fraction. So $1.29 is going to go on the top, and that's for 32 ounces. The reason I'm doing that is because in order to compare these, I'm going to want to say, well, if I get 1 ounce, how much is that ounce going to cost me? I don't want to divide by 1.29. First of all, I don't like dividing by decimals. That's a little bit more challenging for me. Second of all, I don't want to know what 1 penny will buy me, because if I go to the store and try to buy part of a shampoo bottle or a sports drink bottle, they're not going to allow me to do that. So in this case, if I want to find out what happens for 1 ounce, I'm going to have to divide the denominator by 32. Then I'm also going to have to divide 129 by 32 as well. So I'm going to look. My guess is 32 is going to go in there about 4 times. If I do 4 times 32, I'm going to get 4 times 2 is 8. 3 times 4 is 12. And I'm going to get 1 when I subtract. What I have to remember, though, is 32 doesn't go into a dollar to 1.29 4 times. That decimal in place needs to come right up with me. 32 didn't go into 12 anytime, so that 0 needs to carry up as well. I could add another 0 here, bring it down. Well, 32 doesn't go into 10. What I noticed right away is if I'm working with money, I know that money can't go more than 2 decimal places. We only go into the hundredths. So I'm going to have to put 4 cents here as my total. I don't have to continue on with the division because, again, I'm going to have to round anyways to get my answer. Now if I look at the other sports drinks bottle, it tells me that it's $1.20, and that's for 24 ounces. So this time, to get 1 on the bottom, I'm going to divide by 24, and that's going to give me 1 ounce. And then I'm still going to have to divide the top by 24. And let's see what happens here. Again, I'm going to bring my decimal up. 24 doesn't go into 12. It's going to go into $1.20, looks like about 5 times. So if I do 5 times 4, I'm going to get 20. And 5 times 2 is 10, plus that 2 that I carried up will be 12. So if I subtract that, I get 0. So this one was 5 cents per pound, or per ounce. So notice I'm actually paying less per ounce here. So this is going to be my better value. Even though it's 9 cents more expensive, for the number of ounces I'm getting, it's going to be the better deal. At this point, go ahead and try the other example on your note skeleton that's going to help you use unit rates to help you determine which is the better value or buy.